Assalamualaikum warahmatullahi wabarakatuh. My name is Din Shafiq bin Muhammad Rashid, and I will present about Let 3 friction loss in pipe. This is my team member. These are all my team member: Muhammad Wafi, Muhammad Zikri, Abdul Rahman, and Amir Aiman. And my metric ID is MA17018. So the first one is abstract. An experiment titled Determination of Friction Loss in Pipe was carried out to fulfill a requirement of engineering fluid mechanics lab. The effect of viscosity, movement of fluid molecules against each other or against the wall of the pipe cause friction loss in uniform strip section of pipe. It is greatly influenced by whether the flow is laminar. The Reynolds number is 2000 or turbulent. Reynolds number is 4000 in this case. For this experiment, straight pipe, elbow pipe, and 90-degree pipe are being tested. So next one is conclusion. Head loss, pipe coefficient, loss coefficient, Reynolds number, and so on are all considered. Friction, additional accessory, and elevation variation will all cause losses in flow of fluid via a pipe. These losses may be reduced by selecting the appropriate pipe diameter and fitting for the system. Straight pipe, elbow pipe, bend pipe, and 45-degree angle bend pipe are all employed in this experiment. I think that's all for my part. Thank you for your time.
And I will be presenting on chapter 1, which is introduction. For this project, we will be analyzing fluid flow in pipe network and investigate the variety of fluid flow rate measurement methods, which including rotameter, orifice, and also venturimeters. On a pipe pressure descent, the impact of skin friction to be nailed out, and the tube connection will also be investigated. This will be the formula for the Darcy-Weisbach, consisting of HF equal to FLV squared over 2dg, and HF is simulating loss of head due to friction, L is for length of pipe, D is the diameter of pipe, V is mean velocity for the flow in the pipe, and lastly F, which is the friction factor of Darcy-Weisbach. Minor losses in pipe flow occur due to fitting, valves, gradual and sudden expansion or contraction, as well as the admission and exit effect, in addition to skin friction losses. In most cases, losses are measured experimentally and correlated with pipeline flow, which is RE over D parameter. The loss factor coefficient of K is used to describe the friction loss caused by the fitting. This will be the problem statement. We want to figure out how much the major losses are worth. If we don't know how much they are worth, we won't be able to move on to the next step. The loss in the length of tubing is measured as a function of discharge in the experiment. The objective for our project is to determine the pipe's major, minor, and friction loss, as well as the complete fluid flow measurement technique. And the last objective is to investigate the amount of velocity for various type of pipe with various diameter. This will be the scope, which is will be scoping for the laminar or turbulent flow, and investigate the different type of diameter for pipe on velocity, and the friction factor will be linked to the range of flow rate. That will be all from me. I will pass on to our next member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdurrahman bin Bedu, matrix number MA19293. In this video, we will discuss about the theory chapter 2. First, we will discuss about the head loss equation, how to find the head loss. And then we will discuss about the Darcy-Weisbach equation to find head losses for turbulent flow and laminar flow. And then we move to the friction head loss for both laminar flow and turbulent flow, the equation of the friction head loss for both laminar flow and turbulent flow. In theory, we will discuss about the function of Reynolds number and how to find it. And then we move to the next one is friction factor, how to find the friction factor for laminar flow and turbulent flow. And then last one, we will discuss what the relationship between HL, head losses, and KL, resistance. That's all. Thank you. Assalamualaikum.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zikri Hilmi bin Muhammad Daud. I will present chapter 3 about methodology. Okay, first, method and procedure. This is figure 3.1, the setup of the experiment. Okay, next, I will tell about experiment apparatus. Okay, first, fluid friction apparatus. Second, hydraulic bench. Third, pressure sensor. And lastly, data measurement and data acquisition. Okay, next is experiment procedure. Okay, first, all the equipment is examined to check if there are any damage. Second, the pressure sensor are interconnected with the DAQ and NI. Third, two pressure sensor, input and output are adjusted to the straight pipe, which is the desired tested pipe. Okay, next, the main switch and pump are enabled. Next, by rotating the control knob, the flow rate of water is adjusted, starting with the maximum flow rate and steadily decreasing the flow rate of water. After that, the flow rate reading is obtained from the flow meter or the computer. Okay, next, the computer reads the pressure reading from both sensors. Okay, repeat step 2 until sit for elbow pipe, bend pipe, 40-degree bend pipe, and 90-degree bend pipe. Any of the information gathered is recorded. Okay, next I will present about the experiment precaution. Okay, first, after taking the measurement, the parallax error should be stopped. Second, when fluid is moving, the manometer reading will fluctuate. Carefully record the mean position. Okay, lastly, maintain a sufficient level of fluid in the inlet and outlet supply tank. Okay, that's all. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amir, metric number MA18075, and I will discuss about the result for the lab 3 friction loss on pipes. So this we have the calculation data for the pipe configuration, the volumetric flow, measured head loss, measured friction coefficient, velocity, Reynolds number, calculated coefficient of friction, and calculated head loss. Next is the discussion. So for the first question, which explain how the strange gauge sense the pressure. So when the pressure is applied, the strange gauge sensor will either stretch or compress. So the amount of deflection caused by the pressure in axis parallel to a metaphor pattern with current run through it will change the resistance. Means that external force is converted into electrical signal. So for question 2 is what will happen to the head loss if the diameter of pipe decrease. So referring to Darcy equation, when the pipe diameter decrease, the head loss increase. So the third question is, which are the two types of energy loss associated with the pipe flow? And then from the experiment result, which one is the most significant loss of head incurred by the following flow along the pipe? So there are two types of energy loss in pipe flow. So the major losses which associated with frictional energy loss due to medium viscous effect and pipe wall roughness, and minor losses due to pipe fitting, changes in flow direction and flow area. And then from the experimental value, minor losses caused by the pipe fitting has the most significant loss of head. Okay, so question 4, how can we find the value of minor losses coefficient for experiment? Of course, from the equation of minor losses due to component. And then lastly, question number 5, which is compare our Reynolds critical number with theoretical value, which the transition from laminar and turbulent flow occurs. From the calculation, the Reynolds number is up to 600, while the critical Reynolds number is 2300. Means that flow is laminar flow along the pipe. There is no transition of laminar and turbulent. That's all for me. Thank you.